So in today's lesson, we'll be learning about the different types of plate boundaries, how they work, why they're important, and some of the different types of features that are associated with each one. So if we look at the interior of the Earth, at the top and all around, we've got the crust, so it's a thin, quite rocky layer. And then underneath, we've got the mantle, which is a semi-molten layer of rock. So if I type that out for you, semi-molten, oops, wrong color, just change that. But semi-molten means that the rock's been heated up so much, semi-molten, it's been heated up so much that it behaves almost like a liquid. It's quite elastic even. And then we have the outer and inner core. It's made out of iron and nickel, so very heavy metals. And it's actually hotter than the surface of the sun in our core. It defines a lot of the magnetic properties of our planet, which is quite interesting and cool. So the crust, as I mentioned, it can be split into different types of plates of different sizes. So you can see there's some big ones, like the South American plate, the African plate, and there's some small ones like the Nazca and the Cocos plate. And so our crust is split into these plates, and where these plates meet, so areas like here between the African and Antarctic plates, a triple junction over here between three different plates coming together. So for example, it looks like a little bit like this. So that's called a triple junction. So these areas where the plates meet, they're called plate boundaries, unsurprisingly. And these plate boundaries are very, very dynamic. There's a few different types. There's three that we'll be covering today. So we've got divergent plate boundaries, we've got convergent plate boundaries, and we've got transform plate boundaries. And we'll see why they're important, how they work, and what we can find on them. So if we make a start with divergent plate boundaries, it's where plates diverge. So diverge means to move away from something. So if something is divergent, it's quite different, it's away from the norm. So these two plates are moving away from each other. So if we get like a 2D sketch of this, so that's one plate, this is another plate. So one is moving this way, and another is moving this way. And what this does is it creates a gap in the middle and if I do it in an orange color, so it looks like fire, we get magma rising up in this gap and out of the gap to come up onto the surface. And if it's not already a volcano, then the magma, because say if this is in an area like the Mid-Atlantic Ridge, so Mid-Atlantic Ridge. So if this is in an area like the Mid-Atlantic Ridge, then that means it's in the middle of the ocean. So because it's so hot, the magma, it's going to cool down straight away and it's going to turn into a rock. So it's going to turn into new crust, so new oceanic crust. So hence, that's why it says new crust has been formed. And it'll layer up on top of existing layers and an existing rock over here, and it'll just form new crust. It's new rock being formed. And so once that's happened, if we get enough gas and pressure being built up inside the magma chamber, which is over here, then the magma will erupt to the surface as lava and it'll form a volcano. And this can happen in the middle of the sea, or it can happen on land. But it's mostly in the middle of the sea because this is where we get divergent plate boundaries forming. So if I type divergent plate boundary here for you. Okay, now if we look at convergent plate boundaries, what does convergent mean? It means where two plates converge, they're moving towards each other. So we've got the oceanic plate and the continental plate. Now you must have thought there was only one type of plate, but in fact there's two. The oceanic plate, as I just said in the previous slide, it can be formed, it's new. I've said the word new a lot because it's being born. We can form readily formed crust by diverging the plates and magma coming up to solidify continuously over periods of time, whether it's hundreds or millions of years. So we've got new oceanic plate, it's younger, but it's also denser because it's formed by a type of rock called basalt. Now basalt is quite heavy and dense because it's made out of minerals that are quite iron and magnesium rich, and they come from deep inside the mantle. On the other hand, you've got the continental plate, and it's made out of granite. Now granite and basalt are the two most common types of rocks that you'll find on the entire planet. And the continental plate is easily deformed, but it's also a lot older. than the oceanic plate. Okay, so if I write that down, the oceanic plate is denser, so it's dense, but it's also young. An emphasis on the word new. And then if we look at the continental plate, it's old, so it's lighter, it's old, and it's deformable, meaning it can easily have its shape changed to different types of dimensions based on the position of the plates moving towards each other. Now what happens here is as one plate moves towards each other, it's denser, so it'll have a tendency to sink. So you get the oceanic plate and the continental plate moving towards each other. The oceanic plate's denser, so it sinks, but that sinking motion is called subduction, hence the name subduction zone. I'll just change the color. So this area over here, this slanted region, is called the Benioff zone. It's quite a high level term, but that's the zone where you get the two plates rubbing against each other. That's the plane on which it happens. So you can imagine that this zone, if it's extended in 3D, would look a little something like this, because this is a 2D view, and this is where it's happening. That's the Benioff zone. And we experience a lot of friction, and friction means heat. So this rock is being heated up continuously and it becomes molten. Remember, molten behaves like a liquid. And as we get a lot of these fractures forming in the different plates over here, because there's a lot of stress in this area, there's a lot of stress, there's a lot of strain, so it forms these fractures and these faults. And so the liquid behaving magma can move up through these fractures up directly to the surface, and it can erupt as a volcano. Now what can also happen in this type of scenario, so we've confirmed there's volcanoes here, what can also happen is we can get earthquakes, because again there's a lot of friction and there's fractures being formed, and say if one plate gets stuck, it'll continuously being stuck and it won't keep sinking, and that energy will build up over time, and once it slips, then you'll get a release of energy that's been collecting over hundreds of years, and that'll result in quite a deadly earthquake. And similarly, in a divergent plate boundary, while